My name is Yusuf. I'm a solutions architect based in Johannesburg, and one of the things that I've over the last 2 years that I've been extensively involved in across multiple education institutes is helping them move their LMSs to AWS and helping them architect it to take advantage of the cloud. So we've got public use cases of large universities like Wits University that moved their Sakai LMS in the first few months of the COVID pandemic, early 2020, and since then I've been fortunate enough to be involved in multiple Moodle migrations and new Moodle builds on AWS. So for the next 20 minutes or so, I'm going to go through just a few slides, and then I'm going to jump into a demo of what it takes to be able to provision a Moodle environment on AWS. I'm going to show the benefits of infrastructure as cloud, and how the different layers of the Moodle architecture, your application, your database, your caching, can all be accelerated. How you can save costs, and how you can really efficiently serve your students. I'd appreciate if you ask questions at any time. So let's try to make this as interactive as possible. So please feel free to stop me, not only on chat, but come off mute and ask a question. So like a few of the customers that I've dealt with, where they've got a Moodle cluster on premise, it's using on-premise infrastructure, and that takes weeks and months to be able to set up, and like what we've seen during COVID, but again, I mean, we were seeing these before COVID and still now, is that when the demand changes, it's difficult to be able to respond effectively and quickly enough to student demands, to be able to give them, to be able to scale up your Moodle application quickly enough. And then even when you are scaled up, it means that only during exam time. So if you're using your Moodle only for assessments, or if you're using it even if a mix of learning and teaching, is that only during peak periods are you effectively using your environment. But during times, at nights and at weekends, when usage is low, you effectively over provisioned. So again, these are again some of the issues that customers have mentioned to us, to be able to meet the sudden surge in demand, and after a cycle 3 to 5 years, when your hardware is aging. But I mean, it's not only that. If you're upgrading to a new version of Moodle, and you want to be able to test it out, it's very difficult for you to be able to use your on-prem environment. Perhaps that the test or dev environments that you do have are either being used, so they're not free to be able to test a new version of Moodle, or you simply don't have it, or you'd like to be able to test it a little bit more in a production use case, or you want to, because maybe it's a major version change in Moodle, and you need to be able to retrain your the academic staff, the support staff and students. Having multiple environments on-premise infrastructure does become a challenge. So why customers moved to AWS is because of our proven ability to be able to run at scale, to be able to meet the different demands. And again, when I talk about scale, it's when we don't only talk about scale out, we also talk about scale in, which is when your students or when your usage on your environment is not that much, AWS has ability to scale in, so you can save costs. And even in the event of failure, because failures will happen, by building a Moodle across AWS, across multiple availability zones in the region, or even multiple regions, and using using CloudFront as a content delivery network, allows you to be able to really resist and withstand multiple failures. And again, it's highly secure, and I'll show you that throughout the demo. So I'm gonna be referring to the slide, or at least this reference architecture throughout the demo. So I'll quickly walk you through it. So if you look on the top left, this is where your users start, and this is where they start interacting with the environment. They come in via route 53, which is a DNS service, and that will manage manage your DNS environment and allow you to be able to point your users to either your dev or your prod environment. Your users will then start accessing their environment via the content delivery service CloudFront, which will help you to be able to take load off your backend servers. There are over 300 CloudFront locations throughout the world, which means that you can bring your static content, your images, your video, and other media content very close to your users. So you reduce latency and improve the student experience. And then you start hitting your actual environment. So the application load balancer will balance requests across multiple availability zones. In this picture, or in this architecture, we're only showing 2 availability zones, each consisting of Moodle instances, and this is in an auto-scaling group. So as your load increases, your load balancer will notice that, and will create additional Moodle instances. And then to be able to handle that additional load at the different layers of the architecture, you have different layers and types of cache. So the first type of cache is the application cache or session cache running either on Redis or Memcached. That will help people to protect the database. The database is in a master and standby. So in different availability zones, you've got multiple databases, and then you have a shared file storage using Elastic File System, EFS, and this allows you to be able to share files and any other content. So even if your students are uploading attachments or exams and scripts and files, this can be stored in EFS and made available across multiple availability zones to your Moodle instances. So I'm going to go into the demo. I'm going to stop sharing the presentation and switch over to my browser. Is there any questions while I'm doing this? Again, would love to have your questions. Okay. That. Anybody? Because I can't chat. So just checking that you can see my browser.
Yes.
Okay. So it starts off with how do you provision Moodle in AWS. And I'm on a GitHub page, which is where we've published the Moodle reference architecture together with infrastructure code. It's specifically we're using AWS Cloud Formation, which allows you to be able to automatically and very quickly provision a complete architecture. So this is a bunch of CloudFormation files and scripts that we've openly published and changes. Many third-party companies or universities have come in and published changes to this. Someone to change the database from MySQL to Postgres to Aurora, or they want to change the Elastic Cache from Redis to Memcached. So all of this can be done in the CloudFormation templates. If so, you're welcome to use the reference architecture that we've published now, or you can go and make changes. So for instance, this version is based off Moodle 3.8.3, but if you want to move to the latest version of Moodle 4, you can wait for us to be able to make those changes, or you can go ahead and make the changes in the scripts and then go ahead and publish. So and when we talk about publish, it's as simple as saying, okay, you come to this page and you choose in which region you want to be able to deploy this. So I'm just going to choose the the first region, and it will log me into the to my AWS account into the CloudFormation console. It will read the CloudFormation scripts from that from GitHub, and it will allow me to be able to parameterize the different configurations of Moodle. I choose my SSH key. I choose where I want to be able to host or allow SSH from. I choose how many availability zones that I want to host Moodle across. Again, this will impact how highly available and how many points of failure you willing to tolerate. It allows you to be able to customize the network and the subnets. I can choose a different performance mode of different features. For my file system, I can choose different types of I/O. In terms of security, you can choose not only when you enable encryption, you can enable encryption on your database, on your file system, but you can also choose which encryption key using. So you can choose to use your own encryption key, or you can choose to be able to use an AWS encryption key, and the KMS service, key management service, will go and help you change your keys, rotate your keys, and do all key management tasks. It allows you to be able to choose the type and the size of your database, the different caching tiers that you have available in Moodle, and choose how many instances you want. So at the moment we're starting out at one, but I'll go and show you how you can choose to be able to host Moodle on a single instance when there's very little utilization, or up to thousands of instances. When you having learning and teaching sessions or exams, right? So I've gone ahead and pre-built an environment, and you can see how it worked. I provisioned it this morning. I call it the Moodle Ubuntu Net Demo 1. I started it at 8:54 this morning, and it finished provisioning at 9:13. So it took over about 25 minutes with no user interaction. You simply go and you choose the different parameters that you want, and it goes and it provisions this entire architecture of application, database, caching tiers, shared file systems, everything. Any questions before I jump into the different parts of the application? If you think this is maybe I need to focus in on a specific part, or maybe I need to go deeper or go more high level. If you can guide me. Okay, so your Moodle instances, or where the application architecture starts off from when you actually serving traffic is on your load balancer. So this is how a load balancer looks. You simply simply choose that you want a public load balancer. You either expose it on 80 or 443. If you do it on 443, you can upload your own SSL cert, or you can use AWS's certificate manager and manager service, and it will provision certificates for you and auto renew your certificates. So you don't have to do all the manual tasks of renewing certs. So on this load balancer, it has a public endpoint, but I can simply choose to say, okay, let me access Moodle, and if I go into the cloud formation and I go to what is the output of it. So it went and it built this entire cloud formation, and built this Moodle environment, and via the load balancer, I can now access Moodle. So this is the install screen of Moodle, and after you just configure different things about language, which are stock standard to Moodle, you have a fully provisioned Moodle environment consisting of a load balancer, consisting of multiple instances. So currently, at the moment, where the Moodle application is installed, it's installed in a single AWS instance, and and scaling in and scaling out is again a simple configuration. So we would choose to say that in my launch configuration, I want to say I want to choose how I want the scaling to be able to be done. So I'll go into the auto scaling group, and it will tell me that I've currently asked it for it to be a single instance, but that can be easily changed. It will automatically change, and this is where you instruct the load balancer to say that you can go up to 100 instances, and go down to say minimum of 5 instances. But currently now, let's say I want 50 instances. You can automatically set it like this. So maybe an exam is about to start and students are going to come in. A few thousand students will come in at 8 a.m. or 2 p.m. But if you expect the traffic to grow organically as students come in because of learning and teaching, the load balancer will automatically scale the Moodle instances and a Moodle application up to depending on the parameters that you've configured here. The other part of the Moodle reference architecture, so we've spoken about the load balancer, we've spoken about auto scaling groups. We can perhaps go into the database. Now databases can be, on-prem can be challenging, but AWS using the RDS service, relational database service, makes it very, very easy for you to be able to manage your database. You simply choose it. You simply instruct RDS what database you want. So the CloudFormation asked it to give us a Postgres database. You could choose MySQL, SQL Server, Oracle, whatever you want, whatever Moodle supports. In this case, we're using a cloud AWS version database called Aurora, which supports MySQL and Postgres. So we're actually using Aurora Postgres. And what we've done is we've said that it must create a reader instance and a writer instance. So your writer instance, your master instance is in one availability zone, while your reader instances is in another availability zone. And in the event of failure, Aurora will automatically switch. So it keeps your data automatically in sync all the time, and it will automatically switch instances over in the event of a failure. Perhaps the hardware that this database was running had a problem, or an entire availability zone failed. You won't even know that there was an outage. AWS will switch the DNS records to the standby instance, and your application will just continue uninterrupted. You can see that it also indicates to you what you're monitoring. So it tells you what your CPU load, how many database connections, and other monitoring things. RDS also makes it very easy for you to be able to do backups and snapshots. These are fully automated. You simply choose how often you want the backup to be done, and AWS will automatically take a backup, and it will keep the backup for a specific time that you've chosen. And when you want to do a restore, you simply choose the backup or the snapshot, and you can choose to be able to restore to that specific snapshot at that time. So this makes it very, very easy when you need to do Moodle upgrades. And if an upgrade didn't go well, you can simply switch back. Okay, so we've discussed up till the database. Now we can even look at the caching at the caching tier. In this case, we're using the ElastiCache server. So ElastiCache is a fully managed Redis or Memcached service that AWS manages for you. You just tell it what flavor you want, either Memcache or Redis. And via either the console, like I'm doing now, or the CloudFormation infrastructure as code. You instruct AWS to be able to deploy Redis or Memcache, and you instruct it what type of nodes and how many nodes and where those nodes are. So in this case, we're using Memcached. We've currently got 2 nodes, and AWS will fully manage these nodes. And if you want more, you simply come and choose more. Again, it makes all the information about your database, about your instance available. You can see metrics around memory, CPU utilization, all available in the console. And then obviously the last service is the shared file system. I'm cognizant of time, and I want to give plenty of questions, at least plenty of time for questions after that. So I will leave you with a number of blog posts. This is a blog post that I've written based on my experience of how to scale and optimize Moodle. So it tells you about the infrastructure as code, and how you can choose which version of Moodle you want. You customize it to configure the different types of databases, either MySQL or Postgres or any other types of database. It takes you through how you can verify that it will support your expected load of 10,000 or 20 or 30,000 students by doing load testing and even running your load testing in AWS on separate environments that you can simply throw away after you've done your load testing. And then after you've done that and you're running in production, it shows you how you can use cost management or financial management techniques to be able to lower your costs. So this is over a 2-week period with a customer that I worked on. When they started the exam, they weren't sure of the load that they needed. So they started with very upsized databases and instances. And as time went by and as they wrote different exams, they were able to build to right size and scale down the infrastructure without impacting any of impacting the student experience, but making sure that it can scale in appropriately. And then once you're sure of how your Moodle is behaving over a few weeks or months, you can go lock in up to 72% of savings by looking at different pricing models using savings plans or reserved instances. I'll also share about how the University College London moved their Moodle environment to AWS, how Coventry University migrated their Moodle environment to AWS, and the lessons learned from Idaho State University of how they moved their Moodle environment onto AWS. I'll leave it at that and happy to take any questions.